All right, I'm going to try to do pages 4 and 5 in the same video. So on page 4 of the study guide, when we are stating which postulate or theorem proves the triangle is congruent, remember our choices are side, 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 angle, side, angle, side, angle, 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 side, which is the same as side, angle, angle, and hypotenuse, leg. And what I would just say is if it spells ASS forwards or backwards, we're going to write none here because that won't prove that these are congruent. So we need to mark any applied congruencies in this first one. I want to mark that shared side, and then I could see that there's an angle side angle pattern there. And the second one, boomer, sorry, my cat's meowing. We've got vertical angles, so we have angle, angle, side. And this one, they share that side. It would be that ASS pattern, but that's a right triangle and that's the hypotenuse, so that's hypotenuse, leg. Be careful here. We have vertical angles. If I look at this top triangle, it has an SAS pattern, but if I look at this bottom one, the pattern doesn't match. It has the SSA or ASS pattern. So it's problematic that it doesn't match, and then this is problematic as well. So we'll say none. Over here, we don't have enough information, so we're going to say none. This is side, side, side. Excuse me. Oh my goodness. This one we don't have enough information, none. And this one is a side angle side pattern. Moving on down the page. Number 21, this isn't meant to be confusing. We've just been working with triangles so much. When it says quadrilateral, a quadrilateral is just a four-sided polygon. So if yak is congruent to left, that just means that there's some four-sided shape that's YACK and some boomer and some other four-sided shape that's LEFT. So if I read this, angle C, that's going to be congruent to F because they're both the third letter. So I'm going to write angle F there. Angle Y is going to be congruent to angle L. Angle K is going to be congruent to angle T. Oops, that's a T. And angle A is going to be congruent to angle E. And then we could fill out the sides doing the same thing. A and C are the second and third letters, so E and F. Those are the sides that are congruent. K and Y, the last and first, I'm going to use T and L. C and K, the last two letters, I'm going to use F and T. And then YA, the first two letters, that's going to be LE there. And if you draw a sketch, we could see like these two would be congruent, those two, those two, those two. Okay. Moving on, using the picture at the right, name the angle included by the sides BC and AC. Well, it's going to be this angle formed right here, angle C. So it's the one that appears twice in that statement, that letter. That's the vertex. The side included by angles, by angle A and angle B. Well, if I look, angle A and angle B, they include this side right here. That's side AB. All right, we're going to move on to page 5 of the study guide. And so in page 5, we've got some proofs to complete, and these shouldn't be too bad. Don't put them off. So this first one, I'm just proving the triangles are congruent. I'm given the fact that AE bisects BD. So that means AE cuts BD in half. I'm also given that angle B is congruent to angle D, and I got to find one more congruency here. Well, it should jump out at us that we have vertical angles. So then if I look, how are those two triangles congruent? Well, they have an ASA pattern. So that's really all the info we need. So for our statements, I'm going to copy my given. AE bisects BD. And then angle B is congruent to angle D. We said the reason for that is it is given to us. And that, if I look at what's in my given, I'm really only given this pair of angles. So I do have to come back and say, like, how did I conclude that BC is congruent to CD? So in my proof, I'm going to say that BC is congruent to CD. And if I think, like, what information told me that? Well, we were told that AE bisected that. So that's going to be the definition of the bisector. Or I could just like say in words, like I could say in words because AE bisected. So bisects BD. So I could really come back to that if I need to, the way I worded it over there. All right, and then we said that these two angles are vertical. I can't call them both angle C, so I could say angle ACB is congruent to angle ECD, and that's because vertical angles are congruent. So vertical angles are congruent, or I could say the vertical angles theorem right there. And then lastly, we have the 3 criteria for angle side angle in our proof. So we could now say that our triangle AC, oops, I'm gonna mess that up apparently. Our triangle ACB is congruent to triangle ECD, because that's what we're trying to prove up here. And that's because of angle side angle congruence. All right, moving on, number 24. We're doing another triangle congruence proof here. We're given that AB is congruent to BD. And the other congruence we need is this one. And I would point out that these are right triangles. We know that that is also a right angle because that's a linear pair. So when we go to write our statement here, the only thing we're given is that AB is congruent to BD. And that's because that is given. What I would say next here is that triangle ABC and triangle DBC are right triangles. And we could really just come back to what the definition of a right triangle is. So by definition, triangles with right angles are right triangles. And then lastly, we could say that BC is congruent to itself, and that's that reflexive property. So if we come back to this, why are these two triangles congruent? Well, this is an example of hypotenuse leg. So triangle ABC is congruent to triangle DBC, and that's because of the hypotenuse leg theorem. All right, last one, and then this video will be done. Remember, anytime you have these, I would draw the two triangles separately. So triangle PST, and then the other one, that's a P right there. We have triangle RPV. We're given that PT is congruent to PV, and then we're also given that angle T, boomer, is congruent to angle V. So I've got to think, like, what other thing do they have in common? Well, if I look, they both literally share the same angle P. And we said anytime that happens that it's a shared side or angle, that's that reflexive property. So if we go to this proof, I think this one's actually a little easier than I first thought it might be. Our given statement, we're going to say that PT is congruent to PV, and that angle T is congruent to angle V, and that is given. Our second statement, we're going to say triangle, nope, I'm like looking at the proof right here. Sorry, before we can get to that, we've got to think about why they're congruent, and then also what do they have in common. So we said that angle P is the same on both. So I could say angle P is congruent to angle P, and that's that reflexive property. Let's see, and then if I look at how these are congruent, I probably should have thought about this before we started the proof. This is the ASA pattern. So when we prove these congruent, we're going to use that pattern. So triangle PST is congruent to triangle PRV. And since we've established the two angles and the pair of sides in our proof, we can now state that's true with ASA.